All right, welcome everybody to ACT Math Review. This is part three. This is Mr. Tui, and we've still got Abby with us. Say hello to everybody, please, Abby.
Hello, everybody.
Thank you, Abby. You're awesome. And we're still rolling through this ACT practice test. We're going to see the level of difficulty kind of bump up a little bit. So if you saw some of the earlier videos, you're like, those are easy, I've got those. Well, we're going to see some tougher questions here as we head a little bit later into the test. So I think you're going to appreciate that. So go ahead and read question 21. Start us off with that. We'll go from there.
All right. To get a driver's license, an applicant must pass a written test and a driving test. Past records show that 80% of the applicants pass the written test and 60% of those who have passed the written test pass the driving test. Based on these figures, how many applicants in a random group of 1,000 applicants would you expect to get driver's license?
Oh, my. What in the heck are we solving for here, Abby?
How many people out of the 1,000 can get a driver's license?
Yeah, how many do you expect to get a driver's license? And that's, of these 1,000, I guess 80%. It says 80% of the applicants pass the written test. And then 60% of those who pass the written test pass the driving test. Does that make sense?
Yes.
Okay, good. Do you have any idea how to solve this? Have you dealt with percentages before? Do you know how to calculate this?
Yeah, I've dealt with percentages. I don't know with this particular problem. Maybe just go through it. Yeah.
Let's just start with the basics here. Let's talk about what percent means, just sort of in general. Okay. Percent comes from two Latin words: per, which means out of, and then cent, which means 100. Yeah, have you ever studied Latin before? Maybe I've asked you this. I don't know if I have.
Yeah, we've talked about it.
Okay, good.
Not a lot, but I know. Yeah, century, 100.
100, right? Yeah, century is 100 years in a century. There's 100 cents in a dollar, all that, right? So percent means out of 100. So 80% is actually a number. You can describe it as a fraction or decimal. 80% means 80 per 100, so that's 80 out of 100, or 80 divided by 100. Or it's the same thing. If you punch that in your calculator, you should get 0.8. It's the same thing, or 0.80. Does that make sense?
Yes.
So let's start here. If you want to find 80% of something, it's real simple. Just multiply that value by 0.8, and you'll find 80% of it. Does that make sense?
I think so.
Okay.
So would that be 0.8 times 1,000?
Exactly, yeah. Yeah, which you might even be able to tell me logically, but go ahead and calculate it. You've got the calculator, on every question in the ACT.
800.
It's going to give us 800. So think about what this means here before we move on. That means there are 800 students of these 1,000 who pass the written test. From that first part right there. Does that make sense?
Yes.
Okay, that's our 800 value. And then it says, of those 800, 60% of those pass the driving test. So how do we find out how many passed the driving test?
Well, now we're working with 800 instead of 1,000.
Exactly,
so
right? That's kind of our starting point here, yep.
60 over 80. 800.
Well, right? How do we find 60% of something?
Are we still using the decimal? So
yeah, I would still use decimal here, right?
Okay, so yeah, 0.6.
0.6, right? 60%. I want to make this really, really clear. 60% is the same thing as 60 divided by 100, which is the same thing as 0.6. So if you want to find, 60% of something, just multiply it by 0.6.
Yeah. Okay.
Does that make sense?
Yes.
Okay. So go and do that right now. So it would be 800 times 0.6, and what does that give us?
Okay, let's see. 480.
480? Do we see that much up on any of the answers? Yeah.
Yep, right there, B.
That's choice B. Booyah. Any questions about that?
Nope, I don't think so.
Okay. Yeah, I think just understanding kind of what percentage means just helps so much when you're calculating percentages. So
because you know what you're working with.
Yeah, exactly. Right, exactly. So that's it. And we'll see more percentage questions. They love it on the ACT. I think we've already seen at least one already, maybe a couple. So we'll keep working with them. All right, let's move on. I have no idea what's next. I don't remember. Let's find out here. Okay. All right, let's see what's going on here. Oh. Looking like we got some ugly algebra here. Go ahead and read question 22 for us, please.
If A, B, and C are positive integers, such as a to, squared b? Or
a to the power of b.
A to the power of b equals x. and c to the power of b equals y, then xy equals what?
Ooh. What are we solving for here?
Xy.
We're solving for xy. Yeah. They're testing us here on some operations with exponents.
Mm-hmm.
That's what they're testing us on. Is that pretty clear?
Yes,
Yeah.
I think so.
Okay.
As integers.
Yeah. Yeah. We've got some operations with exponents. I mean, we could plug in, like we're solving for xy, so we could just plug in a to the power of b for x, c to the power of b for y. And if we did that, you'd get a to the power of b times c to the power of b, right? You get that. Does it make sense why that's xy?
Yes.
Yeah, because they tell us that AB is
X.
X.
X
So,
and
yeah,
Y.
we're just plugging that in for X, and then C to the power B equals Y, so plug that in for Y. We did that there. But notice we don't see that matching up any of the answer choices, which kind of stinks.
Yeah.
So what do? A couple ways to approach this. We could approach sort of algebraically with the operations with exponents. We may talk about that. I would start with creating values for A, B, and C.
Okay.
I would start there. Does that make sense?
Yeah,
We've done this
for
before,
sure.
right? Let's create some values for A, B, and C. I'm going to start by making let's make A equal 2. I know we've talked a lot about maybe like plugging in ones and zeros, and that's great for a lot of questions. But here, because we're raising A to a power, like 1 to the power of 2 is going to be the same as 1 to the power of 3 and 4, and 1 to the power of 100. It's going to all be the same, right? Because 1 to the power of anything is 1. So to help differentiate the answers a little bit, I'm going to mix it up. Let's make A equal 2. Okay. And then we're going to make, let's make C equal 3. Okay, once again, just to help us differentiate between the answer choices. Does that make sense?
Yeah. Yeah.
And I think for our purposes now, I'll bet we can keep B as 2 as well.
Okay.
If we need to change that to 3, we can change that to 3. But we'll start with 2. Smaller values in general are easier. But you can't just do ones and zeros here because we're just going to get a bunch of answer choices that give us the same thing. If A and C are 1, everything's going to equal everything. So we've got to differentiate a little bit. Does that make sense so far, what we're doing here?
Yes.
Okay, good. So let's plug in these values. So let's plug in, we'll plug in our 2 for A and a 2 for B. So we're calculating basically what X is if we plug in a 2 for A and a 2 for B. So X equals 2 to the power of 2. Does that make sense?
Yes.
Okay. What's 2 to the power of 2, Abby?
Would be 4.
4. Absolutely. Good. 2 to the power of 2 just means 2 times 2, so that's 4. And then Y is going to be what? What's Y going to be?
3 to the power of 2,
3 to the
correct?
power of 2.
Okay.
Which equals what?
9.
9. So what's X times Y, right? That's the question here. What's X times Y? If all these values hold, what's X times Y?
Oh, wait, I'm not paying attention. Hold on.
Yeah, you could. I appreciate your honesty there, Abby. Really do.
Is it just 4 times 9?
Yeah, should be, right? I mean, X times Y should be 4 times 9. So what's 4 times 9?
Which would be 32?
Check that again. Why don't you use that calculator?
Oh my gosh.
Yeah, that's all right. That's all right. That's all right. You got that calculator. Use that calculator.
36. Oh my gosh.
36. We're good. All right, so X times Y equals 36. Is that clear?
Yes.
Okay, good. So we know for these values right here, X times Y has to equal 36. The right answer choice has to equal 36. So let me clear some space, and we'll plug those values in and see which answer choice, or answer choices. We might get multiple answer choices here. We'll see. They give us 36. But we can at least narrow it down. Let me see you plug those values into answer choice F. Can you do that on the whiteboard? Just find a clear space.
Yes. So I'm doing 2 times 3 to the power of 2, right?
Correct.
Is that right? Okay.
Correct.
2. Is that right?
That's perfect. That's perfect.
Okay.
Yeah. That's answer choice F. Do you know what that equals? Do you know how to calculate that?
It would be 2 times 3, which is 6.
Ooh, I'm stopping you. Hold on. We got to PEMDAS. PEMDAS. Let's go back to the rules.
Okay.
Let's go back to the rules. Let's do it.
Oh, okay.
Let's
So would it be 3 times 3 first?
Hold on just a minute. Yeah, so we got to do parentheses first. There's nothing to calculate in the parentheses here. The next is the exponents. Yeah.
Yes, okay. So, would it be 3 to the power of 2 first?
Yeah, it would be 3 to the power of 2.
Which is 9.
Yeah.
Times 2 is 18. Correct?
Correct.
Okay.
So that's 18. Not answer choice F then, right? Because we're looking for 36. Does that make sense?
Yes, it does.
Okay, good. Well, let's test answer choice G. I'll clear some space here. Let me see you plug into answer choice G.
And then do I just write 2? How do I do that when it's 2b like that?
Well, what's 2b mean?
2 to the power of b?
No,
yes?
It's not 2 to the power of b. That 2b just means 2 times b, right?
2 times. Oh, okay.
Yeah.
So
it's like 2x
4?
means 2 times x. That'd be 4. Yeah, so just put a 4 there. That's fine. And you could say 2 times 2, but 2 times 2 is 4. Yeah, absolutely. Mm-hmm. Okay, great. Do you know how to calculate that?
You start with in the parentheses, which I've just been reminded.
Yeah.
So 3 to the power of 4.
Yeah.
Which is, let's see, because I'm not going to do this in my head.
No. I don't know what the answer is myself. So, yeah, just use the calculator. Do you know how to do that with the calculator?
81.
Yeah, that sounds about right. Yeah, because 3 to the power of 3 is 27. So, yeah. And then 81 times 2. I don't even care what 81 times 2 is. It's not going to be 36.
Nope.
You know what I'm saying? So,
yes. G is not it.
Yeah, absolutely. Okay, great. Let's try answer choice H.
Oh, yep, that's my cue.
Yeah.
Okay, 2. Oh, okay. So, how do you want me to do this with the parentheses?
Well, just do 2 times 3, right?
Yeah. I mean, that's
and
what
keep the 2 times 3 in parentheses. Oh, I see what you're saying. Yeah, you can do double parentheses if you want. Like parentheses around this. Just to make the relationship more clear. Yeah. Right? To the power of b is 2.
B,
right?
which is 2. Yeah.
So you could do that.
Oh, my bad.
You're good. I'll get rid of mine.
Oh,
you could do that.
Can you get rid of mine?
or to make it more clear, I think, here maybe just do 2 times 3. But you know what 2 times 3? I mean, 2 times 3 is 6, right? I mean,
6, yeah.
Come on, so. All right, so 6 squared. What does 6 squared equal?
36.
36, which is what we're looking for. So
let's see.
Keep answer choice H, right? Because it could be right. Now again, I got to clarify this. I probably mentioned this on some other questions, right? If you get something that matches, wonderful, keep it. But you really need to test all the other answer choices if you're creating your own values, like we are here.
Okay.
Does that make sense?
Yes.
Yeah, you just have to, because we could see other answer choices that give us a true statement. We'll keep H. But let's try J. Let me see you plug into J.
Okay. Let's see. 2. Put this in parentheses. 3. Which is 2. So it's 4 again. Just like that.
Yeah. So we got to PEMDAS again. Calculate what's in the parentheses.
6.
6, and then what's 6 to the power of 4? I don't think it's going to be 36, is it?
No.
What is it? I'm just curious.
No.
Can you calculate it real quick?
It's 1,296.
Oh, that's huge.
Possibly.
Yeah, that's huge, right?
Yeah, I mean, way too big.
If 6 to the power of 2 is 36, then 6 to the power of something bigger than 2 is not going to be 36. So, anyway, we know it's not J. Let's try K.
Was that right? Yeah. That's right. Okay.
Yeah. We got the same thing as J, right?
Exact same
thing, so we know it's not K. And we can confirm it's answer choice H. Yeah, that works.
Woo.
Any questions about that?
I don't think so, no.
I haven't done this question in a while, so I wasn't even certain those values were going to work. I mean, it's nice that they did here. If you plug in some other values, you're plugging some 1s here, I'm guessing you get a couple answer choices that give you the same thing. But at least you could narrow it down, probably, and get rid of some bad answer choices. Let's talk about the algebra a little bit on this, because this gives us the opportunity to discuss operations with variables and exponents, and this stuff does pop up on the ACT, so it's worth knowing.
That's unfortunate.
So I mean, that's just the ACT, but that's reality. So let's talk about operations with exponents. I'm going to give you let me give you an example here. Let's do x to the power of 3 times x squared. Let's do that. X to the power of 3 times x squared. Now, a lot of students, they've seen questions like this before, and they're like, oh, I'm supposed to do something with those exponents. Do I add them? Do I multiply them? I know I'm supposed to do something, but I can never keep it straight. That's kind of how I feel about exponents. By the way, do you know whether we're supposed to multiply those or add those? Do you know? Do you recall?
You add them. I'm pretty sure.
I'm pretty sure you add them too, but let's understand why. And this is what I don't recommend thinking in terms of operations, which most students are kind of taught to math. I coach students to think about what things mean in math. Think about what the notation means, and then you know what to do. So what does it mean to raise something to the power of 3? Let's start there. What's that mean?
Well, you multiply whatever you have to the power. You do it that many times.
You do that.
That was the worst. That was a horrible explanation.
No.
But...
I followed. I mean.
Okay.
I mean, I'm going to reword it for you, but like essentially, you're multiplying x by itself 3 times if you're raising it to the power of 3. Does that make sense? Mm-hmm. So that means x
times x.
Exactly. Does that make sense?
Yes, it does.
And then what's x squared mean?
X times x, just x twice.
Yeah, just x multiplied by itself twice. So x times x. How many times have we multiplied x here?
5.
5 times, so that's x to the power of 5.
Mm-hmm.
Does that make sense?
Yes, it does.
Okay, good. What about, what if we saw this? X to the power of 3 to the power of 4. Ooh, what if we saw that? What do we do there?
This is really what I'm learning right now, but I couldn't. It's just you just add them, don't you?
Well, you don't add them here, right? Because again, think about what the notation means. Mm-hmm. What does it mean to raise something to the power of 4?
Whatever is in the parentheses. I guess.
Multiplied 4 times. So that that equals.
So it's x to the third 4 times.
Exactly. Times x to the power of 3 times x to the power of 3 times x to the power of 3. And this now we can go back to the previous operation, right? Where if you have a like base, which you have here, you can just add the exponents. Or you'd be like, oh, I'm multiplying x 3 times. So that's x times x times x times x times x times x. Does that make sense?
Yes.
Times x times x. A lot of x's here. Times x times x times x times x. How many x's are we multiplying here?
A lot. It would be 18?
No.
No, wait, do you not add the...
Well, it's 3...
Let's just count.
Yeah, let's count them. Yeah, literally.
3, 6, 9, 12.
12. So that's x multiplied by itself 12 times. That's x to the power of 12.
Why did I get...
I don't know.
Oh
don't
my
worry
God.
about it.
I can't add. Oh my gosh.
You're good. Again, you've got the calculator. You got the calculator, so don't worry about it. Or I would just count them there. But that works. But now we know the operation. Okay, so if you see a power raised to a power, you got to multiply the exponents.
Okay. Yeah, see, my math curriculum does not teach me to make it that simple. So
Yeah, that's right. This is why God put me on earth, apparently, is to help people understand math. So I'm happy to. I'm just playing my role. I'm
happy you're here because otherwise.
Well, thank you. I'm glad you're here too, Abby. All right, so let's go back to the question, right? Because remember when we plugged in, these variables for x and y. Mm-hmm. I'm just going to clear some space here. Okay. So remember we got xy is the same as a to the power of b times c to the power of b, right? You remember that?
Yep.
Yeah. So, how do we get that? How do we get that algebraically? We didn't cover this other property of exponents, actually, and I'm looking at it now. Why, and there's one more. There's one more, which is, if we saw this, 2 times 3 to the power of 3, what do we do with that? You distribute the exponent there. Mm-hmm. So that'd be 2 to the power of 3 times 3 to the power of 3. Look, you're multiplying 2 by itself 3 times, right? Mm-hmm. So that's 2 to the power. That's 2 to the power of 3.
2 times 3 times 2 times 3
times 2 times 3. Yeah, but that's gonna be the same as 2 to the power of 3 times 3 to the power of 3.
Okay, I see.
Does that make sense?
Yes, it does.
So another way to express this form right here, it would be a times c to the power of b, which is answer choice H.
Yeah. Okay.
Does that make any
I
sense?
see. Yeah, I was thinking in the beginning that you could just put all that together because, I mean, a times c is just like that. Or it's just another way of writing it, right?
It's another, yeah, they're equivalent forms.
Yeah.
The same thing. But it's not necessarily easy to get to that, to recognize that this is equivalent to this.
Yes.
It's just not easy. But that's, again, why I just love plugging in values.
Mm-hmm.
I think that's probably the best approach for most students on a question like this. Any questions about that?
No, sir.
Okay. Let's keep rolling. All right, question 23. Oh, we got some more algebra coming up.
Oh, joy.
Oh, yeah. Go and read question 23 for us, please.
Which of the following expressions is equivalent to half
Yeah,
y
so that giant mess. Yeah.
You want? Yeah. Okay.
Yeah, don't worry about it. We're good.
Okay.
We're good. Yeah.
To the problem.
Yeah. Well, first of all, let's talk about what that term equivalent means. What does equivalent mean? Do you know what equivalent means?
Equal to.
Equal to. Yeah, equal to. So one of these answer choices is going to be equivalent or equal to this giant messy expression. Mm-hmm. Does that make sense?
Yes.
Okay. Now, there's an algebraic way to do this. We may start with that. I'm not quite sure yet. There's an algebraic way to do this. Really, we're going to have to use the distributive property. You're familiar with the distributive property?
Yes, that's going to take forever.
We could do it. It's not too bad.
Yeah.
Multiply 1/2 y squared times 6x, then multiply it by 2y, and then multiply it by 12x, then multiply it by negative 2y.
Would you want to do all that? Oh, sorry.
Well, I'm just saying you can do all that. There's also a plugging in values way to do it as well, where we can at least get rid of some of the bad answer choices.
Mm-hmm.
Do you have a?
Can you
go ahead.
simplify the in between the parentheses?
Yeah, I would start. I would start there, honestly. Yeah.
Okay.
In fact, I think I want to start with the algebra.
Okay.
On this,
because if you can get it right, that's faster.
Yeah, I think I would do the algebra here. I would recommend over plugging. Sometimes it's better plugging values. Sometimes it's better to do the algebra. Both work. Both work.
Yeah.
Anybody watching this recording, if you want to try doing this with plugging values for x and y, give it a whirl. It's probably more complicated, honestly. I would do the algebra. So let's combine the like terms inside the parentheses. Let's do that. Absolutely. Okay. Start there, and then I think we'll use the distributive property to be much more straightforward that way. Let's do it.
Okay. So 6 plus 12x, because you can move that without changing anything.
Exactly.
Which would be 18x.
I love it. Yeah, when you're adding, you've got sort of that common term in x, right? Those are like terms. You're just adding the coefficients, the numbers in front of it, so you get 18x, and then that's gone. I say scratch those out completely. On a paper test, certainly, we're done with those. I don't want to see them.
Yeah, rewrite the expression.
Yeah.
And then you can move 2y to the right of the other two numbers to make it 2y minus 2y.
Exactly.
Which is
what's 2y
0.
And which is nothing, right? So those are gone as well. Yep. So literally, everything in parentheses.
18x.
Yes. It's really, they're just testing on combining like terms here.
Mm-hmm.
Okay, so it's 18x times, we still have that 1/2 y squared.
What? Now... Okay. This is kind of tricky.
Okay, that's a little tricky, but it's really not too bad. We can still combine like terms. Okay, we can't really, we're multiplying here. X times y is just xy, or x times y squared is just x times y squared. But we can combine this 1/2 and this 18. We can simplify that. What's 1/2 times 18?
Which would be 9.
That's just going to be 9, right? 1/2 of 18 is 9, so that gives us 9. So those are gone now. And then we're left with x and y squared. What do we do with that?
Which would just be xy squared?
Yeah, it's just xy squared, right? We're just multiplying everything. That's it.
Oh, wow.
It. Answer choice A.
Yeah. So if you can just simplify and do the problem, I feel like that's easiest.
I agree. Just kind of one step at a time. And I go back and forth. Sometimes it's easier to plug in values. A lot of times it's easier to plug in values. Sometimes it's just easier to do the algebra. And that's okay. If you're not familiar at all with the algebra here, you can also plug in values for x and y. You'll get rid of some of the bad answers. But if you're familiar with the algebra, I recommend just kind of going through the steps there, combining like terms. Any questions about that?
No, sir.
Okay.
Sounds good.
I think we're good there. That makes life a little bit easier.
Yeah, for sure.
Okay. All right. Go and read question 24 for us, please.
An artist makes a profit of 500p minus p to the second power dollars from selling p paintings. What is the fewest number of paintings the artist can sell to make a profit for at least $60,000?
Ooh, what are we selling for here?
The profit of at least 60,000 paintings.
It's a little more specific than that, Abby.
What is the fewest number?
Yes, the fewest
paintings?
number of paintings you can sell to make a profit of at least $60,000. Okay. So I mean, like, look, if he's selling like 1 million paintings, he'll make, I hope if he's selling paintings for more than $1, he'll make $1 million, or more. Mm-hmm. But we're trying to find the smallest number of paintings he can sell to make at least $60,000. Now, this is a good example here where, like, I wouldn't do the algebra on this. I mean, there's an equation you can set up and you can solve it. You can do some factoring and isolate p. You can do all that. Mm-hmm. There's a much easier way to do this, though, especially because you got a calculator. We can just test the answer choices. Can't we?
I think so, yeah.
Right?
Because you just plug it in for p, right?
Yeah, plug these answer choices in for p, and we'll just find the smallest value that gives us a profit of at least $60,000.
Okay.
Let's do that. Let's just do that. Okay.
Start with F.
Start with answer choice F. Yeah, start with 100. So you're basically calculating,
500 times 100.
Yeah, and I'll write it out. 500 times 100.
Okay.
You can start
calculating. Which is 50,000. And then 100 times 100. So.
What does that give you?
Oh, $10,000.
$10,000?
Yes.
So it's probably
on the. Oh, yeah. Right. So it's. Oh gosh, hold on. Hold on.
I'm gonna double check it well.
500 times 100 is 50,000.
Yeah, 50,000. Minus
100 times 100 equals 10,000. So 50,000.
50,000 minus 10,000. Well, that's not gonna give us 60,000, is it? I think it's gonna be 40,000. Mm-hmm. Once we got 50,000 here, I was like, "Oh, that's not going to work because I'm subtracting from 50,000." So
yeah.
Anyway, F isn't going to work. That's going.
Yeah. So you want to try to get 70 on the left?
Well, we're trying to get
70,000.
Yeah, it's going to have to be something like that. I mean, it's going to have to be certainly bigger than 60,000, but you want over 60,000 altogether.
Okay.
Okay. So let's try answer choice G. So we'll try 500 times 150.
75,000 minus. I did not do that right. Hold on.
Yeah, you can use the squared button, or you can just do 150 times 150. It's the same thing. What are we subtracting from 75,000?
150 times 150. 27,500.
I got 22,500. Try that one more time.
Okay, let's see. 150 times 150. 22. Yeah, 500. Okay.
22,000.
I don't know how I got that.
That's right. Sometimes you just press the wrong button. All right, does that give us at least $60,000?
Yes.
I think that's good, right? I mean, it's just 75,000 minus. And I'm just double checking here because I don't trust my arithmetic either. I got 52,500.
So not enough.
So that's not enough. Does that make sense?
Yes.
Okay, so it's not G. I'll bet H. I mean, we're increasing the number here. I'll bet H works. I'm not certain. But I'll bet it works. Let's see
because we only need a little bit more.
We just need a little bit more. We'll see if that does it. Let's clear some space.
Okay.
So we'll try 200 now. So it's 500 times 200.
500 times 200.
What's that give us?
100,000.
100,000
minus. Let's see.
Oh yeah, that's gonna work.
40,000.
Minus
so
40,000.
60,000.
That gives us 60,000. We can stop there. We can stop there at answer choice H. Any questions about that?
No, sir.
That's not too bad, is it? Once you realize you can test the answer choices.
Yeah, for sure.
Yeah. We'll just go through them. And a good example, again, we're just plugging in values is the easiest path here. I don't think there's any question about that. You have any questions for me?
Nope, I do not.
Rock and roll. Let's keep going. Ooh, we got a little pie chart here, it looks like. All right. I think we've seen another pie chart question already in this review, but go to read 25 for us, please. Yeah.
Last month, Lucy had total expenditures.
It's like fancy word for expenses, right?
Okay, of $900. The pie chart below breaks down these expenditures. Oh my gosh.
Expenditures. Yeah, you're good.
Expenditures by category. The category in which Lucy's oh my gosh. Okay. Expenditures.
Yeah.
Were the greatest in what percent of her total expenditures to the nearest 1%?
Wait, what do we solve for here? Hold on.
The category in which Lucy's expenditures were greatest in 1%. To the near, I don't even know. That's just
it's a really confusingly worded question. It doesn't help that the word expenditures is in there like 4 times.
Yeah, expenses.
Yeah, expenses would be nice, right?
Lucy's.
But if you want to reread that as expenses, that's totally cool, right? The category in which Lucy's expenses were greatest is what percent of her total expenses to the nearest 1%.
Okay.
Do you understand what that question's asking, or no?
Not really, honestly.
Yeah. Okay. So let's break it down. So let's start with the first part here. It says the category in which Lucy's expenses or expenditures were greatest is what percentage of her total expenditures. Well, what's the category in which Lucy's expenditures were greatest? You should be able to just look at the pie chart and tell me.
Category. So clothes?
Yeah, it looks like clothes, right? Yeah, absolutely.
The greatest. Okay.
Yeah, right? That's where she spent the most money. Isn't that the category where her expenditures were greatest?
I think so, yeah.
Yeah. And the question is, okay, that category is what percentage of her total expenditures? So that's some percentage. That might be 50%, it might be 25%, it might be 75% of her total expenditures. Do you understand kind of where this is going? It's some percent of her total expenditures. And we got to find out what percent that is.
Of the greatest one. So when it said the greatest, that's what it was targeting.
Yes, that's kind of, you have to understand what that means. They're talking about the clothes category.
Okay.
Does that make sense?
Yes, it does.
Okay.
I think so.
We've got some options here. There's a lot of options to solving this one. First place I want to start is just with kind of basic logic and common sense and some visual estimation. I mean, does it look like this pie chart is drawn to scale? Do you know what I mean when I say drawn to scale?
I would say yes.
It looks like it, right? I mean,
yeah.
I mean, clothes is the biggest category because that's $254 and that's bigger than all the other categories, but it's also the biggest pie piece. Yes. And the next biggest one is food, which is just a little bit smaller in size, but it's also a little bit smaller in dollar amount as well, right?
Yeah.
You know?
And 125 looks a little bit more, or a little bit bigger than 120, so.
Yeah, it does. Just a hair bigger, but it's darn close, right? But like 125 looks like it's half of 254, which makes a ton of sense as well, right?
Mm-hmm.
I mean, it's drawn, and this is drawn to scale. All the figures I've seen on the ACT are drawn to scale, unless stated otherwise. I think we did see another pie chart one where it said it's not drawn to scale, but if it doesn't say it, all that I've seen are drawn to scale.
Mm-hmm.
So my first question for you is like, what percentage of the chart does it look like that clothes category is? If you were to guess, what percentage? You know what I'm saying?
Yeah, maybe 35-40%.
Well, do you know what?
I'm trying to split it in half.
Do you know what half? I mean, look, you know what half would look like, right? I mean, 50% of if it were like this big around.
Yeah.
Right, that would be 50% of it.
So a little bit more than what, 25?
That's what I'm thinking, right? Because if it were 25%, we'd have like perfect 90-degree angles on both sides. That would be like 50% on both sides.
So maybe like 28, 29,
look at the answer choices, Abby.
Oh.
Uh-huh.
Well, that's pretty easy.
Right? It's not 24%. Do you see that? Mm-hmm. The close category.
It's not 32.
And it's not 32. 32 is too big.
It's 20. Wow, okay. That's...
So just using visual estimation, I would be like, it's probably B. Okay?
It's probably B.
I don't have the answer key in front of me right now. I'm not certain. We're going to calculate it.
Okay.
But that's looking, if this is drawn to scale, and I think it is, I mean, it's looking really good. Mm-hmm. Does that make sense?
Yeah,
okay.
for sure.
Okay. All right. So now let's talk about kind of calculating the percentages here. Here's what we could do. We could test the answer choices. We'll come back to that. Here's kind of a principle I wanna make this clear. And I've seen this apply in a lot of questions. If you want to find the percent of something, Abby, if you want to find the percent of something, just take the part and divide it by the whole.
Okay.
And you'll find the percentage automatically. Okay. So for example, like let's say you've got a 50 question test. All right. And of those 50 questions, you get 45 of them right. Does that make sense? And you want to know, like, okay, what percent did I get right on the test? Okay. And the only reason I know, like, you know, I taught in the classroom for years, so like I've calculated grades a lot. I just know this works. On your calculator right now, I want you to calculate 45 divided by 50.
0.9.
You get 0.9. But 0.9 is a percent. What percent is 0.9?
90?
90%. Does that make sense?
Yeah, it's as easy as that.
Yeah. Because 0.9 is the same as 9 divided by 10, which is the same as 90 divided by 100. I mean, that's it. So take the part and divide by the whole, and you'll always get a percent. It's going to be in, you know, some decimal form. You've got to recognize what percent that is, but just multiply the decimal by 100, and you'll get the percent. Does that make some sense?
Yes, it does.
Okay. So the part in this case is just 254, right? That's the part of her total expenses, right? The clothes part.
So would we add up all the money?
Yeah, if we divide that by the total amount of expenses, but we don't even add it up because they tell us in the question. What's her total?
Oh, $900.
$900. So what's 254 divided by 900?
254 divided by 900 is 0.28222.
Yeah. 0.282 repeating. Right. Which is closest to which answer choice?
28%.
28%. Booyah. Because 0.28 is 28%. It's the same
That's pretty
freaking
cool.
thing. Yes. So we can confirm it, right? But we found it the first way, right? Just using visual estimation, being like, that's just a little bit bigger than a quarter, 1/4 of the total pie, but 1/4 would be 25% of it, so it's a little bit bigger than 25%. It's got to be 28. And it is. There's one more way to find the right answer. There's one more way to do this. We could just test the answer choices as well, right?
Yeah.
Like, remember, it's kind of like what we did on that first question, I think, right? Where we're finding the percent of, like, the people who passed the test, right? If we want to find 24%, if we want to test this answer choice, if we want to find 24% of 900, how do we find 24% of 900?
It would be 24 over 900.
No.
No? Okay.
We multiply by a decimal. What's 24% in decimal form? 0.24, right? So it's 900 times...
Oh my gosh! Yes.
Right?
Okay.
900 times 0.24, which gives you what?
216.
216. And we know that's not right because we're looking for 254.
Yep. Okay.
Right? Let's try 900 times.
Oh wow!
0.28. You see what's going?
Even easier than what I thought. Okay.
What's that give you?
Let's see. 252.
252, which is darn close to 254.
And then if you do check the next one.
We can check the next one, right? So what do we multiply 900 by now to check answer choice C?
0.32.
0.32. I'm doing as well. What's that?
288.
288. Psh, too big. It's got
too big. So 28 is right.
We got 3 ways to find the answer here in this question. Wow.
That's crazy.
It is, and man, this is true for the SAT and the ACT. There's generally 3, sometimes more ways to solve them. There really is. I don't care which way you solve it. Find the way that's easiest for you, that makes the most sense to you. But if one of your ways of thinking about it, if you're like, oh crap, I don't remember exactly how to calculate the percents here, I don't exactly how to figure. Okay, think of it visually. If you don't want to think about it visually, or and you're much more comfortable with the percent operation, do the percent operation. But there's 2 different percent operations. You can calculate it by dividing the part by the whole, or you can test the answer choices as well. Any questions about this?
I don't think so.
Okay, good. I want to give you as many tools in your toolkit as possible, but if you can think about it from all these different angles, you'll find a way on most of the questions to solve it.
I like it.
All right. I do too. Let's keep rolling. And we're back with some geometry.
Oh, yay.
All right. And I know you have not taken a geometry class yet. I know that.
I have not.
Don't worry about it. We can solve this without any sort of fancy geometry operations. Go and read 26 for us, please.
Okay. In the figure below, the measure of angle BAC is x plus 20 degrees, and the measure of angle BAD is 90 degrees. What is the measure of angle CAD?
What are we solving for here, Abby?
The angle of, or the measure of angle CAD.
Yeah, we're solving for the measure of angle CAD. Do you see where angle CAD is in the figure?
Yeah, I think so. Yeah.
Which one is it?
Can
you show me? On the whiteboard? I mean, there's sort of a triangle there. I wouldn't call that an angle. I'd say it's like this. I think I know where you're going with that. It's like that angle right there.
Yeah. But
yeah.
I was, yeah.
Yeah, you're just doing it, making it a little bit bigger. Yeah, exactly right.
Yeah.
But yeah, it's that angle right there. Right, that's CAD. You start with C.
I don't think in angles. I just think to like make the triangle.
Yeah, I got you. Yeah, I recommend recognize it's sort of the middle point is where I guess they call it the vertex of the angle.
Okay.
Right there's A. But yeah, that's CAD right there. Any question about that, or does that make sense?
Nope, that makes sense.
Okay. So we're solving for CAD. They tell us that BAD is 90 degrees. No big shock. I mean, it looks like 90 degrees right there. Good heavens. Right, we've talked about that before. I mean, and again, all the geometry questions I've seen on the ACT, unless stated otherwise, they're drawn to scale. So this is drawn to scale like all the others. All right, that looks like a 90-degree angle, and they tell us it is. And then they tell us BAC is x plus 20. Right? You see where BAC is?
Oh, yeah.
Which angle is BAC? Show me on the whiteboard. Yeah, there's BAC. Absolutely. So that's x plus 20.
Cool.
Well, here's my question for you first. What does it look like BAC is? If you're going to guess in degrees, how many degrees does that look like? I think you can come up with a reasonable guess.
Yeah, it'd be half of 90. Yeah.
It looks
maybe
just a
little smaller.
Exactly, right? Just a hair less than 90. Or than half of 90, sorry.
So,
a hair less than half of 90. Half of 90 would be 45, so like
40,
let's say
maybe?
40 degrees. I mean, it looks like 40 degrees, doesn't it? It's not 45. 45 would be exactly half. It's a little bit less than half. So let's say 40. That'll work for right now. If you guess 35, I don't think it would matter here. I still think we'll find the right answer. But 40 works, and to me, it just looks like a 40-degree angle. So let's say 40. Okay, great. If BAC is 40 degrees, what's the x value?
Oh, are we solving? Like right now?
Well, yeah, I mean, look at this. They tell us BAC is x plus 20 degrees.
So
if BAC is 40, what's x?
40x?
No,
wait. Oh my gosh. Okay, hold on.
You can figure this out.
Okay.
If BAC is 40, what's x have to be?
I can figure this out.
I mean,
2x?
This thing, no, you're still thinking in terms of algebra. That thing's got to be 40. What number plus 20 gives you 40?
2.
No, that'd be 22.
Wait. Wait. Hold on. I thought we were Okay. I gotta rethink this.
Yeah, I think you're just looking at it the wrong way. I'm going to tell you what x is, and it's going to be real clear. X is 20.
20. Okay, so...
It's 20. Because if x is 20, you get 20 plus 20 right there. That's 40.
Oh!
BAC.
I was thinking outside parentheses. I was thinking in algebra.
Yeah, right. Yeah. I knew you were looking at it the right way because otherwise it would be pretty obvious. It's 20 plus 20. Yeah. Does that make sense?
Yes, it does.
And this is where it goes back to this goes back to the way students are trained to think about math, which is like operations based math. You're like, oh, this parentheses there. I'm supposed to distribute something. Is probably what you were thinking, right?
Yeah.
And it's like,
I was thinking what times 20.
Yeah. Right here,
we're just x,
exactly.
and
but we're just adding.
Okay.
Right? Some number plus
adding.
20 is 40. Well, 20 plus 20 is 40. Does that make sense?
Yeah.
Okay.
Yeah. I was
good.
totally overthinking that.
Yep. Yeah, no problem. All right, but I think we're straight now. All right, so we know x is 20. The reason why we want to know x is look at the answer choices. Oh, I just erased that. Hold on. look at the answer choices. They're all in terms of x.
Okay.
So it's going to be really helpful to come up with a value for x or a really reasonable estimate. I think 20 is a very reasonable estimate, maybe perfectly accurate. But we're trying to figure out the measure of CAD in terms of x, right? But what's CAD? I think we know CAD.
50.
It's got to be 50, exactly. Does that make sense why we know CAD is 50?
Yes, because 40 is 50.
Because it's got to add up to 90 degrees, right? Because BAD is a 90-degree angle. So 50 degrees for CAD. That's what we're solving for. So the right answer choice has to give us 50 degrees
Okay.
when x is
so
20.
it's-
Does that make sense?
Yes.
You can just look at the answer choice and tell me what's the right answer here.
G, right?
It's got to be G, and it is.
Cool.
Booyah. Booyah. I mean, look at some of these other answer choices, right?
Yeah, those are crazy.
Crazy, right? It's not going to be negative. It's not F. You know, H is going to be too big. 70 plus anything. It's not just BAD is not going to be bigger than 70 degrees. It's just not. Or CAD is not going to be greater than 70 degrees. And J and K are crazy too, because X just isn't going to be that big. You can come up with a reasonable estimate for X because you can come up with a reasonable estimate for BAC. And then it's just logic. And a little bit simple arithmetic. Any questions about that?
I don't think so.
On these geometry questions, make it as concrete as you can.
Okay.
Think in terms of actual values, you can figure it out.
Yeah, try to insert the X, and then it's easy.
And then it's very easy. All right, that's good there. I don't want to get into the operations. There is an operation, but it's not helpful. All right, not the last geometry question we're going to see. In fact, we got another one coming up here. Oh, boy. Here we go.
It's good practice.
It is good practice. Go and read question 27 for us, please.
What is the perimeter in inches of
The isosceles right triangle.
Oh my gosh.
Yeah.
Isosceles?
Uh-huh.
Okay. Right triangle shown below, whose hypotenuse is 8
times the square root of 2.
Okay, inches long.
Yeah. Yikes. There's some vocab in here we probably need to discuss. First, let's talk about that term isosceles. Do you know what isosceles means?
Isosceles. Obviously not, because I haven't even read it before.
No problem. That's right. Yeah, that's right. You haven't taken geometry yet, but let me explain it. So an isosceles triangle, it's a triangle, or an isosceles right triangle, but really any isosceles triangle is a triangle where the two angles at the base equal each other. That's an isosceles triangle.
Oh,
it could take a lot of, and you've seen it before. I mean, it could take a lot of different forms. I mean, it could be like this. That's not a right triangle, but that's an isosceles triangle because the two angles at the base are equal, roughly.
Okay.
They are there, essentially. So, does that make sense what an isosceles triangle is?
I think so, yeah.
It's worth knowing that term, but even look at the picture because it looks like they're equal, right? If you just look at the figure. So, we can use that. And then they say, so we got to find the isosceles, the perimeter. Well, let's talk about what perimeter means. What does perimeter mean?
Outside?
Yeah, you add up all the lengths on the outside. So we got to figure the perimeter all the way around.
In inches
Of that triangle.
Right triangle.
Right? So we got to add this value here. We got to add to this value here and add it to this value here. We'll get the perimeter. Add up all the sides. Does that make sense?
Okay. I think so.
Let's talk about this term hypotenuse. Right? And some of you just knowing what things mean. Do you know what hypotenuse is?
I do not.
Hypotenuse is the longest side of a right triangle.
Okay.
It's the longest side. So could you show me which side is the longest side of this isosceles right triangle? One side is longer than the others.
Bottom?
Yeah, the bottom one, right here. This guy. That's the hypotenuse. Yeah. There's right triangles could take other forms. That's a right triangle right there, roughly, assuming this is 90 degrees. Let's say, hey, there we go. I put the symbol there, so now it's 90 degrees. This would be the hypotenuse right here. Right, that.
Yes,
long side, right? And it's always opposite the 90-degree angle. That's the hypotenuse. Okay. Does that make sense? We're going to actually come across this later. I think we've got a SOHCAHTOA. We've got trigonometry. You haven't taken geometry yet, let alone trigonometry.
Oh, my gosh.
We're going to solve a trigonometry question. I think you're going to understand it.
Cool.
So it's worth knowing these terms. Okay, so the hypotenuse of this puppy is 8 times the square root of 2 inches. I'm going to label that real quick. It's 8 times the square root of 2 inches. We got to come up with the perimeter of this thing. So there's kind of a fancy math thing here. We're going to talk about that a little bit later, but first let's practice just using logic and visual estimation. Okay. Now it's tough doing that as long as we're dealing with 8 times the square root of 2, because I don't know exactly how big that is. Okay. But we can turn that into an actual number. It's really easy if you got your calculator. Just calculate what the square root of 2 is. Just press 2 and then the square root button, and then multiply that by 8, and we'll get a value for that hypotenuse. Does that make sense?
I think so, yeah.
Yeah. Go and calculate that real quick. So find the square root of 2 and then multiply it by 8.
Okay, you'll have to give me a second to get my calculator to flip.
Turning my iPhone sideways here.
Yeah. Okay, so we've got... Oh my gosh. Why can't I figure out how to do this?
So it's just... do you see the square root button?
Yes.
Okay. So just do 2 and then press that square root button. You'll get some number. It's a little bit less than
Crazy.
2, but bigger than 1.
Yeah.
Yeah, but it's a long decimal. What did you get?
1.41.
Yeah, great. Right. That sounds
yeah.
perfect. Right. And then just keep that number there and then multiply it by 8. So times 8.
Which is 11.313.
Yeah, that's what I got. Let's say 11.3. Yeah.
Yeah, 11.3. Okay.
So I'm just going to use that decimal for. I think it's just easier to understand.
Yeah, because it's more of a whole number for sure.
Yeah, I mean, it's a decimal. I wouldn't call it a whole number, but I mean, like, it's
whole
just,
number, but it's more of
it's just
in your
easier
head
to
a whole
understand
number.
it's easier to understand what that means. Like
Yeah.
11 point, if you say like, oh, we're wrapping up in 11.3 minutes, like I know what that means. But if you tell me we're wrapping up in 8 times the square root of 2 inches or 2 minutes, I'd be like, I have no idea what you're saying.
Yeah.
So okay, good. This is gonna make it easier to deal with visually. We know these other sides aren't as big as 11.3. Right? Because they're not the hypotenuse, and they just look smaller, right? Don't they look smaller? I mean, if I were to like superimpose that, those other two sides, which are equal, but I mean, they look like they're equal. They are, by the way. In fact, we know they're equal because the angles opposite those sides are equal as well. So the sides are going to be equal.
Mm-hmm.
Okay. So that's the thing. It's, with the isosceles triangle, it's not just that the angles at the base are equal. 2 of the sides are also equal. Those 2 sides are equal on an isosceles triangle. It's worth knowing. But they look equal here, so that's good enough. So if I were to draw that side length here along the hypotenuse, it would look something like that. Maybe a little bit smaller. Does that roughly look like the same length?
Yes.
This and that right there in green? I think so. So if that whole hypotenuse is 11.3, what's a good estimate for those other 2 sides?
So it'll be smaller than 11.3.
Smaller than 11.3,
so
but not like crazy much
smaller. Yeah, you can take out what? D and E.
Well, don't worry about the answer choice just yet. Don't worry about those just yet. Because we haven't calculated the perimeter yet.
Okay, so it probably
give me a number.
8 maybe?
Yeah, I would say 8. Something is a really good estimate. I mean, it's not, it's not 10, smaller than that. I mean, it's like a little bit more than 2/3 of 11.3. It just looks like 8. That's good.
Okay.
Right? Shouldn't surprise you much because we see a bunch of 8s and multiples of 8 in the answer choice as well. But if that side is 8, we know this side is also 8. It's the same side. I mean, it's the same side length. Does that make sense?
Yeah, so you can just insert the 8.
So we can just calculate the perimeter now, right? We just add up all the sides. So let's add them up.
16 plus 11.3. 27.3.
So we got 27.3 for a perimeter. And again, that's just an estimate, but that's darn close. Okay? I feel really good about that estimate. So let's pick the answer choice that gives us something close to 27.3. Okay? We might get a couple that get us something close. I'm not quite sure, but look at answer choice A, right? Mm-hmm. Do you see why that's such a bad answer?
Yeah, because it's a whole number.
Not just that, but I mean, like, it's less than 11.3. It's less than one of the sides. It's not going to be the perimeter, right? All the sides added up. A is way too small. What about B?
Wouldn't that just be 16 to the root of 2?
No. So you're thinking about operations again.
Oh, okay.
Don't do that.
Okay.
No,
okay.
Don't do that, right? We know what 8 times the square root of 2 is. What's 8 times the square root of 2?
11.3.
11.3. We've already calculated it. So it's 11.3 plus 8.
Oh, okay.
Right?
Yeah. Yeah, which is not it.
That's just too small, right? Does that make sense?
Mm-hmm. Yes.
Don't try to do math things.
Okay.
You can't add them up like that. I mean, that's like trying to add 8 plus 8x. Those just aren't like...
which you totally cannot do that.
It's not 16x. That's not. 8x
and I
plus,
know that. So
yeah,
that was
exactly, right? And by the way, like, operations with variables are very similar to operations with square roots. You have to, if you want to add the coefficients, you got to have the same square root.
Yes.
So,
okay. Yeah, anyway. I knew.
But that's just too small. What about answer choice C? What's that equal?
Oh, 16. So you want me to use my calculator?
Let's calculate that thing, right? It's the square root of 2 times 16.
Mm-hmm. Okay, let's see. And then times 16 equals 22.6. Which, that's still not big enough.
It's closer. Yeah. But I don't think that's big enough.
Oh, okay. Maybe. So we are using D and E.
Yeah. Let's go to, what about D? I might keep C because it's close. You know what I'm saying?
Yeah.
Maybe our estimate's off. I'm going to keep it. Try
Okay.
D.
D is just what? 16.
16. Okay.
Times.
No, it's just 16.
Oh yeah,
Right?
yeah, yeah.
So it's not D.
Yeah,
That's definitely too small. Let's try E.
Okay. We just did So 11 point. Wait, did we already do 8? Yeah, 11.3 plus 16.
Yeah.
Is that right?
Yeah. What's that give us?
27.3,
Booyah.
which is the exact number.
Exactly.
So you know that's
the same calculation, right?
Yeah.
Like your estimate for 8 was spot on, but really, like when I did this the first time too, I was just estimating visually. I guessed 8. I mean, it looks like it.
Yeah, for sure.
It just looks like it. But even if
what if you didn't? What if you didn't guess 8?
Well, if you guess something like 9? Let's say you guess 7.
Okay.
It might be between C and E, but even C is still smaller, even if you guess 7. But it's just, you know, or if you guess 9, I think you would still be the close. If you get 7, 8, or 9, you're still going to be close. I don't think anybody would be guessing.
Okay, good. No.
Nobody's guessing 6 for those two sides.
No.
Because it's just it's bigger than half. It's closer to 2/3. So 7 to 8 or 9 would be fine. I think you'd still get it. Or at least you'd have a 50-50 shot between C and E.
Okay. But, I think I would have guessed I did guess 8, but I was between 8 and 9.
Yeah.
So.
But look at answer choice E more closely, right? I mean, this is basically the calculation we did. 8 times square root of 2 is 11.3. And we added that to, 2 times that one of those sides, right? So, I mean, it's just it's 8 plus 8 plus 11.3. That's exactly what answer choice E is. It's in the right form as well, right? Because we know the hypotenuse is here, and then we're adding 2 of the sides. So I think even if you guessed another value for those 2 sides, I think you might still be able to recognize the form. But you got a good chance between C and E. But we were able to find it exactly. So
yeah,
I think that's still the best approach for most students. Now, there's another way to think about this too. You're supposed to recognize that this is a special kind of triangle here, and I do want to explain this. This is a special kind of triangle called the 45, 45, 90 right triangle. Okay. Let me explain why we know it's a 45, 45, 90. Because we have a 90-degree angle in this isosceles right triangle, right? There's 90 degrees right here. It's 90. We know, look, all of the angles in a triangle have to add up to 180. I think we might have discussed this previously on another question. You remember that? All the angles have to add up to 180?
Yes.
Yeah. And we know these 2 angles here have to equal each other, right? Because it's an isosceles triangle. It's the definition of isosceles. So those 2 angles have to add up to 90, and they've got to be equal. The only way it's going to work is if those angles are 45-degree angles.
Okay.
Does that make some sense?
I think so, yeah.
Okay. It's the only way it's going to... We got to... those angles have to be some value that makes everything equal 180, and they've got to equal each other. The only values that are going to work are 45.
Okay.
I mean, if it's 30-30 and 90, you're not getting 180 degrees. Or if it's 50-50 and 90, you're not going to get 180 degrees. It's got to be 45, 45, and 90. Does that make sense?
Okay. I think so, yes.
Okay. 45, and this is really for other students watching the recording. I know you haven't studied this yet, but I'm guessing some students watching the recording have.
Yeah,
This is a special kind of right triangle called the 45, 45, 90, and the sides have a special relationship with each other. If this is some length x, this is also some length x, right? Because those sides are equal.
Yep.
And then this is going to be x times the square root of 2. They just always appear in that sort of ratio. Okay. So if you studied that before, look, if you see some triangle and something times the square root of 2, I think you can pretty safely assume you're dealing with the 45, 45, 90 right triangle, which you are here.
Cool. Okay.
So right. So yeah, and in this case,
that.
it's 8 times the square root of 2. So you can be like, oh, so x is 8. So it's just 8 plus 8 plus 8 times the square root of 2. But that's going to be answer choice E as well. If you can recognize that form. Does that make sense?
Yes.
If you see a triangle with something with the square root of 3, you're probably dealing with a 30, 60, 90 right triangle. Again, there's just a common ratio of sides here. Oh, that's kind of an ugly triangle here. Let's make it a little bit more. Okay, there we go. That's better. That'd be a 30, 60, 90. I just want to kind of go over this with students that may have studied this before and refresh their memories here. 30, 60, 90. They have a special ratio. If this is x, this is the hypotenuse is 2x, and the base is x times the square root of 3. On the SAT, they're kind enough to give you this figure, and they also give you the 45, 90 figure on the SAT.
Mm-hmm.
You don't have that on the ACT, so you might as well know it here. Study this, copy this, screenshot this, whatever. But but know these forms. But again, you don't even need that because you can kind of look at it and figure it out visually. I like the first way of looking at it.
Okay.
Does that make sense?
Yes, it does.
Okay, good. Let's do a few more. All right, go ahead and read question 28 for us, please, Abby.
Okay. In the equation, In the equation y equals ax to the power of 2 plus bx plus c is graphed in the standard xy coordinate plane below for real values of a, b, and c. When y equals 0, which of the following best describes the solution for x?
Whoa, what are we solving for here?
What best describes the solution for x?
What describes the solutions for x? Yeah, absolutely.
Okay.
This is kind of a complicated looking question. I think it's much scarier looking than it actually is. Let's talk about what these things mean here. First of all, they tell us y equals 0. They tell us that. That's important. Okay.
Yeah, because you can. That's already an answer number.
Yeah. So there's a couple ways to think about this. We know we could plug in a 0 for y and get a true statement or some solutions for x, potentially. We could also think in terms of graphing, which I think I would recommend here. Do you know what y equals 0 looks like on the xy axis?
I do not.
Yeah.
Wait. Say that again?
Well, this is an equation. Y equals 0. We could graph that on the xy axis.
Okay.
Do you know what that would look like? It's a line.
I don't.
Yeah. Here's what y equals 0 would look like. Well, first of all, we know, I mean, here's the y axis right here, right? And we know the point 0 has got to be on the y axis if y equals 0, right? Y equals 0 is a horizontal line that goes right through the y-axis at that point. Really, it's y equals 0 is the x-axis.
Okay.
That's the line y equals 0. The line y equals 1, let's assume this is the point 1, right here on the y-axis. The line y equals 1 looks like this. Here's the point y equals 2. Here's the line y equals 3, etc. Does that make some sense?
Gotcha. Yes, it does.
Interestingly, the line x equals 0 would go vertical. It's got to go through the x-axis, where x is 0, and just goes vertically like this. Doesn't matter what y is, x is 0. Forever, for infinity. The line x equals 1 would look like this. Assuming that's the point 1 on the x-axis. X equals 2 would go right there. Does that make some sense?
Yes, it does.
Okay. I think that's real helpful to know here on this question, right? Because we know the line y equals 0 is right there. Okay. So we're looking for the solutions for x when y equals 0. Okay. Now here's a question for you. Let's because most students are more comfortable with this with lines. I'm going to draw a little xy axis just to the right of this question. Okay. I'm going to draw oh, that's a really ugly x-axis. Hold on. There we go. Okay. We got two lines here. Here's one line. Here's another line. Where is the solution to that system of equations? The solution to those two lines?
Is it where they meet?
It's where they meet. Absolutely. Right?
Cool.
Yeah.
I totally guessed.
Yeah, but you're right. I mean, like, it makes sense, right? Those are the x and y values that give you a true statement for both of those equations. Okay. True statement for both equations at that point, whatever x and y is at that point. Okay. So really, this question is kind of a really fancy way of saying how many times do these two lines intersect? This parabola and this line y equals 0. How many times do they intersect? By the way, how many times do they intersect?
Oh, beats me. I don't know.
Well, look at the figure.
Well, right here, 1.
Look at the figure. We've got a parabola, and we've got this yellow line, y equals 0.
So, twice?
So, twice, right here, and right here. Guess what the right answer is here?
Oh. So, would that be F? No. Not. Wait, are you talking about the answers? Is that what you were asking?
Yeah. Now I'm looking. Oh, yeah. Well, hold on. We know there's two solutions, right?
Yeah, so it's either F, G, J, or K. But
Well, we
then
know
you don't
there's
want
two.
negatives.
Yeah. Now the question is, do we have two positives, two
Yes, so-
negatives, one positive and one negative,
Okay.
two solutions that are not distinct, or two distinct solutions that are not real? I don't even know what that means.
So,
Okay.
yeah.
But we know
K doesn't really make sense.
right, but we know we've got two.
Mhm.
Right? Okay. Well, are they positive or are they negative, or are they positive, one negative?
They're
I think
positive,
that's the question
right?
now.
Well, they're with the 0, so I don't know.
Right? Good question. So, I mean, we're looking for the values for x that give us a solution. This value right here in red, that value right there,
Okay.
is that positive or negative? That x value.
That'd be positive?
It's positive. Absolutely.
Okay.
Does that make sense?
Sort of.
Well, is the x value positive or negative there?
It's positive.
It's positive. Yeah. What about this value right here? Is that x value positive or negative?
Positive?
Oh boy. No, when you go to the left of the
No.
y-axis, right? You've
The
graphed
y-axis,
things on the
it'll
y-axis,
be
right?
yes.
I mean, that
yes.
could be the
Okay,
point,
so
like-
it would be negative.
It's going to be negative, right? Because that could be like -1, -2,
Okay.
-3. I don't know if that's exactly what those values are, but I mean, that's the idea, right? Everything to the left of the y-axis is negative.
Okay.
Does that make
So I'm
sense?
gonna think like that. Yes.
So I'm thinking answer choice H. Looks like we have one positive solution and one negative solution.
Gotcha.
Does that make sense?
Yes.
For x, right, which is what we're solving for, the solution for x. Answer choice H. Any questions about that?
I don't think so.
Not, maybe, I mean, you got to be really familiar with the x, y axis, what's positive, what's negative on the x, y axis. I mean, have you graphed before? Is that somewhat familiar?
I just started learning how to do. I don't know why my algebra is not. I mean, I'm sure.
You haven't finished algebra 2 yet, right?
No, I haven't.
Yeah, gotcha.
So
Okay, no problem. But yeah, that's you do have to know the left-hand side. Left of the y-axis on the x-axis is negative. You do have to know that.
Yeah, I didn't know that. I'm just not super familiar with it, so it kind of took me.
Gotcha. Okay, gotcha. All right, but okay, but that's really it. Distinct here just means different.
Gotcha. Okay.
That's all it means, and that keeps popping up.
Whew.
All right, let's move on. Let's do one more. I was thinking we were going to get to the trigonometry. We'll have to save that for our next session.
Okay.
But we'll get one more question in. Oh no.
Oh, it's not good when you say that.
Imaginary numbers here. Much scarier looking than it is. Go ahead and read question 29 for us, please.
What is the product of the complex numbers? You want me to read those out?
Yeah.
-3i plus 4 and 3i plus 4.
Ooh, okay.
We're doing this in algebra right now.
Okay,
so
good. So have you seen
hopefully-
imaginary numbers before?
Yes, I have.
Okay. Do you know what imaginary numbers mean?
Is it -1?
You're close. When you see this
Times.
form I, that equals the square root of -1.
Oh,
The
yes.
square root of
Okay.
-1. It's called an imaginary number. The reason why it's called imaginary is because there's no such thing as a square root of -1. It doesn't exist. Okay, and let me explain why. I mean, if I said, Abby, what's the square root of 16? What is the square root of 16? You punch it in your calculator right now.
Okay.
You know how to solve it with the calculator at the very least. What's the square root of
Gotta
16?
get the iPhone to load. Hold on.
Yeah, that's right.
Okay, let's see.
Square root of 16.
It's 4.
That's 4.
Oh,
Right?
I knew that. Oh my gosh.
You did know that, right? Because it means there's some number when you multiply it by itself, it gives you 16. Does that make sense?
Yeah. Yes.
Okay. But what if I said, Abby, what's the square root of -16? What does that equal? Okay. I'd be curious to see what happened if actually you punch that in the calculator. You might get an error message. But there's no number when you multiply by itself that's going to give you -16. Because if the number is positive, like 4 times 4 is going to give you a positive number, 16. But even if the number is negative, like -4 times -4 is still positive 16. So there's no number when you multiply by itself that is going to give you a negative number. Does that make sense?
Yes.
So that's where this whole imaginary number thing comes from. Okay. So I is just the square root of -1. Doesn't exist. That's why it's imaginary. And the nice thing is you deal with I just like you deal with like x. So if you saw like, I mean, you know what 2x plus 3x is, right? I mean, what's 2x plus 3x?
5x.
5x, yeah, absolutely. Good. So 2i plus 3i, do the same thing. You're just combining like
5i.
terms. So it's just 5i. That's it, right?
Yeah.
So that's all. You do it just like you deal with x. Except there's one exception, though, which is that I squared equals -1. I squared is -1.
Oh,
And the reason for that is that, I squared would be, I times I. And if you square that, the exponent cancels out the square root sign, and you're left with -1.
Okay.
So you deal with it just like you deal with x, except for I squared equals -1. That's really all you have to know with imaginary numbers. Does that make sense?
Yes.
Okay, good. And in this question, they're asking us for the product of -3i plus 4.
So are we adding?
No. That would be
multiplying?
the sum. That'd be the sum. Product means
so
multiplication.
multiplication. Okay,
So
it's
we
either
got to multiply these guys. Basically, they're saying 3i plus 4, in parentheses, times exactly 3i
3i
plus
4.
4. Now here, you've seen this before. You've definitely done this at some point. This is where we're going to have to do something called foiling.
Mm-hmm.
Have you foiled before? You know what that means?
No, I don't.
You've
actually.
probably done it.
I'm sure I've done it. I don't know the term though.
Foil is an acronym.
Oh, okay.
Okay. FOIL is an acronym for firsts, outsides, insides. Sorry for the terrible handwriting.
Nope,
and
you're good.
lasts. Okay, FOIL. So we're going to start by multiplying the first terms. Basically, we're going to have to multiply everything by everything. We got to multiply -3i times 3i. Does that make sense?
Yes.
Let's start there. What does that give us when we multiply -3i times 3i? What's that give us?
-9i. Am I doing math right?
It's -9i.
But
squared.
then it just makes 9.
Well, -9i squared.
Okay.
Does that make sense?
Yes, because there's two i's.
Because there's two i's multiplied. I times I is I squared. We were just talking about that, right? I squared means I times I.
Yes.
We got to multiply the -3 times the 3. We got that. That's -9, but we also have to multiply the I times I. That's I squared. Does that make sense?
Yes, I believe so.
Okay. We're going to be able to simplify that I squared here. We'll do that in just a moment, but let's keep multiplying. So now we're going to do the outsides. So that would be -3i times 4. Those are our two outside terms. That makes sense why those are the outside terms. They're just kind of on the outside of that form. So what's that going to equal?
-12i?
Yeah, so that's -12i. Perfect. Now let's do the insides. That's next. So that's 4 times 3i. What's that give us?
It's +12i.
+12i. Looks like those are going to cancel that. That's nice. And let's do the last terms. 4
times 4.
Which is what?
16.
Which is plus 16. These two terms right here are going to cancel out. Is that obvious?
Mm-hmm.
Yeah. I mean, anything plus its opposite is 0.
It's 0.
So it's going to cancel out. It's going to be 0. We know what I squared equals. What's I squared equal?
I squared. Oh. -1?
-1.
-1.
-1,
yeah.
right? Because I is squared and -1. I squared is just -1. So that's -1 times -9. What's -1 times -9?
Which is just 9.
Just regular 9, +9. So that's just 9. So we're left with 9 plus 16.
Mm-hmm.
Which is what answer choice?
25.
25. Answer choice C.
C.
Excellent. Any questions about that?
No, sir.
Okay. Have you foiled before? Is that familiar now or no?
Yeah. They just advanced distributing is.
Yeah. Oh, okay. That's how you learned it. Yeah.
Yeah.
I like that FOIL acronym. I think it's useful. Just
FOILs,
multiply
cool.
everything by everything. But yeah, it's the same thing as advanced distributing. But that's it there. But just know that you deal with I just like you deal with any other, variable, except that I squared is -1. And if you know that, you get this one. Any questions about this?
No, sir.
Okay. Let's wrap it up there. We will start with some trigonometry when I see you next. And,
oh, joy.
I know. No, that's right. We'll go over all. It'll make sense. I promise. And tackle some of these harder questions on the ACT. But you're doing great. So, Abby, thank you so much for your hard work, your participation. And again, if you like this video, make sure to like it and subscribe to the channel and all that stuff. And be on the lookout for more ACT math review videos coming out soon. All right. Thanks so much, guys, for watching. Thank you, Abby. See you guys soon.